In this video, we'll write the balanced net ionic equation for Zn plus HNO3. This is zinc plus nitric acid. Do note that this is dilute nitric acid we're using here. If you use concentrated nitric acid, you'd end up having different products. But with dilute nitric acid, we get the zinc nitrate and the hydrogen gas. So with net ionic equations, the first thing we do is balance the molecular equation. I have two nitrates here and only one here. So I'm going to put a 2 in front of the HNO3. Two hydrogens. I have a zinc and a zinc. It's balanced. That's the molecular equation. Now we need to write the state for each substance. Zinc, that's a metal, so it's going to be a solid. Nitric acid is a strong acid, so when you put it in water, it's a strong electrolyte. It dissociates into its ions. Nitrates are very soluble. We have zinc nitrate, so this will also be a strong electrolyte. And hydrogen, that's a gas. So now that we have the states, we can split the strong electrolytes into their ions for the complete ionic equation. Zinc, we're not going to split up. That's just zinc. And I'll write the states at the end. Hydrogen has a 1+ ionic charge, group 1 on the periodic table. The nitrite ion, always 1-. Good to remember. So I have 2 hydrogen ions, plus I have, the 2 applies to everything, 2 nitrate ions. And those are the reactants in our net ionic equation. On the product, the nitrate we said is always 1-. The zinc, because there's 2 of these, has to be 2+. Zinc's a transition metal. Kind of odd though, it's always 2+. So we're going to have our zinc ion, Zn2+, plus 2 of those nitrate ions, NO3-. And then with gases, net ionic equations, we don't split gases apart, just H2. So this is our complete ionic equation. Now we can cross out those spectator ions that are on both sides of the complete ionic equation. As I look for something that's the same in the reactants and the products, the only thing I see is these 2 nitrate ions. I have it in the reactants and products. It hasn't changed, so I'm not interested in that. I'm just going to cross those out. And that'll give us the net ionic equation for zinc plus nitric acid. I'll clean this up and add the states in, and we'll have our net ionic equation. So this is the balanced net ionic equation for Zn plus HNO3. You can see that charge is conserved. We have 2 positive charges on this side, 2 positive charges on this, and that mass is conserved as well. We have 1 zinc atom, another here, 2 hydrogens, 2 hydrogens. So that's it. This is the balanced net ionic equation for Zn plus HNO3. And this is Dr. B. Thanks for watching.